Hey grade 12s, I hope you guys wrote well, those who wrote of course, and those who are still to write, I hope you are preparing well. And this video is just going to assist a little bit. Hopefully you will do your part and reap the benefits. Now let's have a look at this question 12 on Euclidean geometry, which marries grade 11 and grade 12. So we read the statement given in the diagram below. Two circles intersect at K and Y. We can see there's point K and there's point Y. The larger circle passes through O, meaning O in the larger circle is a point at the circumference. But now this O is the center of the smaller circle. Very important piece there to note. So we go back and look at that statement. If O is the center of the smaller circle, what does it mean? It means OK or KO is a radius, and OY should also be a radius, right? Because those are lines from center to circumference of the circle. So please do not delay to annotate pieces of information as you read, because reading this like a novel and think you're going to find your way is going to be very difficult. But reading each time, interpreting the statement in the diagram, believe me, it makes the life very easy. T is the point on the smaller circle such that KT is a tangent. There's always a tangent. KT is a tangent to the larger circle. Okay, so if this is a tangent, we would perhaps want to highlight this so that we don't forget it. Highlighter kahle wena Hlobo kush lakabi ayanqhela. So masiyeke and papel, it means this is not a straight line here. Diagram is a bit distorted. Okay, so what do we understand about the tangent? We know that this angle is going to be equal to which angle? That angle, right? That's the in the bigger circle, that's the tangent to the bigger circle, so it's going to be equal to that angle. 10 chord theorem, right? And of course we are told that ty produced, again, once the word says it's produced, it means it's a straight line. Ty is a straight line all the way to W. Let's see, Ty is a straight line, okay, all the way to W. That's the message being sent to us. All right, great. WO produced, again, see that? Produced, meaning WO produced meets KT at E. So this means this line WOE is a straight line as well. All right, so these are very important pieces of information, and we are told to let W1 equal X. It's already indicated. Okay, what can we do with all of this information? Please don't read the questions as yet. Just get into the diagram a bit more. Inspect. So if we look, this angle is equal to this angle as well. So Y, these are angles in the same segment subtended by chord KO of the larger circle. Okay, at the same time, we can now conclude that this angle is also equal to that angle. Why? These are angles opposite equal sides, seeing that those are radii. And in this triangle KOY, that becomes an isosceles triangle. Okay? So what we will appreciate is that that yellow triangle is isosceles. And so those angles opposite the equal sides are going to be equal. Okay, so we have that piece. So what we can conclude is that KO bisects TKY. As you can see, K2 is equal to K3 as a result. All right, what else can we say? We know that this K2 itself is equal to this angle over there. Why? These are angles in the same segment subtended by chord OY of the larger circle. So again, it says WO produced to E bisects that angle KWY or KWT. So there's a lot of equalities. And of course, guys, once we have worked a bit, it is prudent to stay away from trouble now. We don't need to do more. Otherwise, our diagram is going to start looking crazy and we'll start missing the issues that we still need to discover. There's a lot of work for us to uncover here, but we just want to work a bit, get familiar with the diagram and see more secrets so that we can see if all these questions get answered easily. So 12.1. So 12.1, we need to determine 4 angles, each equal to x. How many did we find? 1, 2, 3, 4. So we got all of them. So first of all, we will start and say, okay, we know that K3 equals W1, right, equal to x. That is the 10 chord theorem. All right, that's the first one. Secondly, what do we know? We also know that basically Y2 angle Y2 is equal to angle W1 equal to x. These are angles in the same segment, okay, in the bigger triangle subtended by arc KO or chord KO. Right. So what else do we say? We will then say, well, we know that K2 is itself equal to Y2 and so equal to x. These are angles opposite equal already. KO or OK equal to OY in triangle. Let's name the triangle because this is in a triangle. In triangle KOY. So it helps to say a lot of things. Of course, we could say equal sides, but those are ready. That's why we know they are equal. Great. The last one, we will also list that essentially W2 is equal to K2 equal to x. These are angles in the same segment, okay, in the bigger circle. So we've got all of them. So it means statement, reason, statement, reason, statement, reason, statement, reason. So don't be scared when you see those 8 marks. It just means there is a reward for some of the troubles you're going to go through. So it says prove that angle T, this angle, we need to prove that this angle is 90 degrees minus x. Okay, so how do we deal with that? So looking at what we have, we know that the angle at center is 2 times the angle at circumference, right, in the smaller circle, subtended by ky, or arc ky. So all we need to do is to find that angle at the center and then get our business. Since these are both in terms of x, so it helps us to move along. So we will say, well, angle KOY, perhaps it's not fair to write it like that. We can just write K1 plus K4 should be equal to, okay, sometimes I like to rush, sometimes I don't want to. It doesn't matter. Let's just do it the right way and show that these are together, plus y2 plus k2. We should get 180 degrees. Sum of 3 angles of triangle KOY. All right, so that is the story right there. So this implies that K1 plus K4 plus x equals 180 degrees. Therefore K1, kanti wayengakwazi ukubhala u-K namadoda. This is going to be 180 degrees minus 2x, okay? Great. We will say, but we know that 2 times angle T should give us angle K1 plus angle K4. Why do we know that? We know that angle at center equals 2 times angle at circumference. Right, easy stuff. So this implies that 2 times angle T is going to be equal to 180 degrees minus 2x. Therefore angle T is going to be 90 degrees minus x when we divide by 2. Easy. Okay, so what do we say here? 3 marks. This one is more important. I guess here what matters is finding the value and of course displaying how we got to that answer. But sometimes the answer may not really carry the mark, but since it is more of a calculation, we can accept an answer, but we can still give 2 marks statement here and reason and ignore the final answer. It's not a big deal. So we've got 1A, we've got 12.3. We now need to prove that KE is equal to ET. So we need to prove that this line is equal to that line. Okay, so what helps us to do our job here? Well, if we look at our triangle, we know this angle, we know that angle, we are missing this angle. If we can prove that this angle is 90 degrees, then we know that a line from center perpendicular to chord will bisect the chord. So that's theorem 1. So our job is to zoom into that triangle. Let's highlight it. So as you can see, that blue triangle has only one missing angle, which is E2, which is an angle of interest. So we go and kill it there. Say in triangle, what is this? It's E2 TW. Right, what can we say in there? We know that angle E2 plus angle W2 plus angle T, we should get 180 degrees. Sum of three angles of a triangle. Okay, easy stuff. So we will then write E2 is our target, plus W2, we found out it's X, plus this is 90 degrees minus X equals 180 degrees. All right. So as we can see, these are like terms. They take care of each other already, cancelling. So this proves that our angle E2 is indeed 180 minus 90 is going to be 90 degrees. And so we can make the conclusion that indeed KE must be equal to ET. Why? We know this is the converse. Okay, let's not say converse. We can just say line from center perpendicular to chord bisects the chord. Okay, so very easy. We needed to remember theorem 1. Of course, knowing what we know. So sometimes it helps to keep the diagram as clean as possible. At the same time, work it as best as one can. All right, so I guess uncovering that this is 90 degrees is key. And perhaps the reason here is more important, then I suppose this becomes key. Although we normally don't get a mark for it, this could have easily been 2 marks, but yeah, no problem. We welcome those marks. So 12.4. Okay, we will not be able to answer a 6-mark question on such a small space, not at all. So let's go to the next page. So 12.4. We are asked a question to prove that K is squared. Now we look at KE. Where is KE? There is KE. Now if this is squared, it means 2 things. Do we have this as a common side of 2 triangles? Right? Is that a question? Yes, it is. Or do we have some Pythagoras that we can use here? Because that's another thing. We hardly go the route of the cosine rule, but we can consider it as well. So if we look at that KE, because once you see a square, just know it's a common side of 2 triangles that are similar, right? The triangles have to be similar. Then we know the proportionality of the sides is going to work in our favor there, because one side gets repeated, then the product becomes a square. Or we may need to think of Pythagoras theorem if we have a right-angled triangle where KE is involved. Usually those are the areas that help us in these kinds of questions. Of course, this is the suplexity. This is the higher grade question. It really needs a proper planning. Now, we look at KE. KE is common to this small white triangle over here. Maybe let's highlight it. So what we have is this small blue triangle. KE is a side of this triangle. Right. And what other triangle are we looking at? It's also common to the big triangle. Perhaps let's highlight it as well. So there we have it. Okay. So are these triangles similar? Yes, K3 is equal to W1 and E1 is common. So essentially those 2 triangles are going to be similar. The remaining pair will also match. from 3 angles of a triangle. So these 6 marks are telling us that, okay, our job here is to prove similarity, then use their sides as a proportion. But let's look again. OE, where is OE? OE is a portion of that small triangle over there. Okay, so KE and OE belong in that small triangle. We are definitely comparing those two triangles. WE, as you can see as well, is over here. What color was that? Purple. So WE is that side. As you can see, it really is a side of that big triangle. Of course, to avoid making the triangle impossible to see, we will not annotate that. But we can see that it's definitely those two triangles. So we will write in triangle. We can say KEO and triangle, basically WKE. I don't care how I name my triangles, as long as I'm naming it properly, where the words, or should we say the sides, don't crisscross, that's perfect. If they follow each other, and with a triangle they always do. Now what do we want to say? From the small triangle, we know that K3 is equal to W1. This is proved above, right? Also, we know that angle E1 is common to both triangles. And once we prove two sets to be equal, we can make a conclusion that triangle KEO is indeed similar to triangle WKE, because two angles we proved equal. And if we prove two sets, the third set is going to match. So there's no point in going through it, because it's quite a weak statement to make after we have made those two. So what do we say? We can say this implies, or perhaps we can say then, just to keep the argument going, then we know that KE over, now remember the ratio is always made by the sides opposite the equal angles in the two triangles. So KE in the small one is opposite O2. O2 will correspond with K1 plus K2, and that is divided by WE. So this means WE comes down there. This is going to be equal to, of course, we look at this one. OE is from the small angle, triangle, divided by OE is opposite the K3. K3 is equal to W1 on the other triangle. The side opposite that is KE. So we can just say proportional sides of similar triangles. They will give us that ratio. And of course, final job is just to do cross multiplication. Therefore, KE squared is going to be OE times WE, not KE. Goodness, that's WE. I'm losing my focus here. And it's exactly as we were asked to do it. So this is good. So of course, guys, what is more important here, although this was a mark, we can give it and give it over there. This statement and reason is powerful. And of course, the final answer, although it's too weak, but it comes from some manipulation. So we will accept the fact that that should be an answer, since it ties up nicely to what we just did above. Alright guys, so that would be the one for just some easy 20 marks. So of course, keep practicing and keep learning. you will get better at it. You will get very excellent at it as long as you keep working. But of course, realize something, guys. Not all of us are built for the same things. Sometimes when this thing kicks you out and it just shows you're not supposed to do it, be honest with yourself. But at the same time, when you can see that you need a bit more of work to get around it, because you can see it but just not clearly as you wish, then keep pushing. But you will see when you are hopeless in the subject, and don't persist, because that's a waste of time. But when you can see that you've got it in you, it's just that you need to get there, don't give up. But be honest, as I said, not everybody can do the same thing and achieve similar results. Sometimes you can do it, yes, but you'll probably not get the results that you are hoping for, because remember, guys, when we publish and popularize excellent results, we're trying to create the impression that everyone who does the subject must get those marks, and that's not the case. Trust me, those things don't matter. Sometimes in your line of life, or what God has for you to do in this world, it may not even be related or aligned with those marks. Just what you can get is good enough to get you where you need to go. So realize those things, guys. We don't have to win the same. All that matters is for us to progress in our lives, and more importantly, achieve our vision, right? Let's dream less, but have more of a vision about our lives, because those are things we can work on and perhaps achieve. Dreams, it's a mere fantasy. Sometimes you will get to your dream and not like it at all, because you never thought deeply about it. You just saw people showing off and you thought you want to do the same. But remember, exhibition is usually a scam. It's never really the reality before you. It's created to make it look like a reality so that you can be captivated. And of course, there's a propaganda behind it. It's either you are to be a paying spectator or observer. And of course, folks want to make money, and they can do it at all costs. But let it not be at your detriment. You shouldn't be the collateral damage. Rather benefit from what you get involved in. If you're not benefiting, there's no point in being there. Anyway, guys, I'm going to preach until Jesus comes back. At the end of the day, you've got to practice. Please go and do it. Take this paper or this question, just draw it. Write those questions again and attempt them, sometimes differently than the way I did it, so that you can see if you are learning something or not. Otherwise, guys, see you next time. Goodbye.